by, it has swung by, when it rotates by theta, so there's a point P. Find the angle of system at the initial when AB becomes horizontal. Where is the instantaneous axis of rotation? It is here. If this is theta, what can be this angle? Theta by 2 from the geometry. Then this, let's bring that omega. Rolls without slipping. I think unless you have not understood this rolls without slipping, you'll land in a big trouble. Now let's come for this one. In rolling motion, so there are two options are there. No, we can describe the motion by standing somewhere on the ground, motion about the center or about toe. You can describe motion of the system about toe, or you directly come at instant center, then the whole system will appear to be having only rotatory motion. So which will be much easier? Will you stand here, hand separate like a here, the moment you release, give some small push, then the torque due to that will act mg, then your friction will act, then right equation and so on, or you directly come here, come to instant center. This will be much easier for you. No, in these two positions, like from where this angular velocity acquired, decrease in gravitational potential of this particle, decrease in gravitational potential particle, that is what converted into the kinetic energy of this ring and also that of the particle. I'll get omega as a function of theta. Then from there, I'll bring alpha. I think there's the first problem where I'm bringing alpha in instantaneous center. Nothing wrong. We can think like this also. So we'll do one thing. Decrease in potential energy. Of particle equal to increase in kinetic energy of ring and increase in kinetic energy of particle. Like a let's also we will solve problem by standing at P. And what is P? P is an instantaneous center. Sir, why P, sir? Why not on the ground? Then we have to enjoy the question if you stand on the ground. So can you show this omega about O? No, all points will rotate about center of mass of system. Where center of mass of system? I think you have to, very dangerous, sir. All of you getting better. There's no option for us discussing about instantaneous center only. Because what is the same? If stand on the ground, the whole particles will, the whole points on a rigid body will rotate about center of mass. Center of mass of system will come here now. I think very complicated. I tried, finally I suffered, then I came here. If you want to try, not possible. Decrease in potential. Okay, this will become mgr 1 minus cos theta equal to increase in kinetic energy of ring, IP omega square by 2, that of the ring, that of the particle. Torque equal to I alpha. Again, you have to solve for friction. see, like, okay, you are comfortable. Okay, carry on. I don't have objection, but I am not comfortable. Increase in kinetic energy of particle. What is the angular velocity? All points should have same angular velocity. So therefore, the same expression will put it. So it's of that of the, I think we'll do one thing. That of the O about point P, we'll write like this. That of the particle about point P, this one. Let's substitute all. I think this mgr 1 minus cos theta LHS, no problem for everyone. What is the moment of inertia of the O? mr square IO. For your benefit, I'm expanding this. That of the particle. What is the distance? So this distance will be 2r cos theta by 2. So directly it is of omega square by 2 m into 2r cos theta by 2. Square is only for this one. So I naught is mr square as it is a ring. So this will become omega m 4r square cos square theta by 2. Okay, further we'll simplify. I think m will get cancelled out, so there won't be 2mr square here, m r square. So this will become r square omega square. Here 1, 2. So this will be 2 omega square r square cos square theta by 2. One r also gets eliminated. Then what all we'll get expression for omega as a function of theta. Then from there I'll bring the alpha. G into 1 minus cos theta g by r. Omega square I'll take outside. 1 plus 2r square cos square theta by 2. Only r. 1 r. That r we have sent it, no? Oh, okay, this will be. This, to get alpha, we are going to differentiate with respect to theta. Then theta equal to 90 degrees. So shall we show that alpha here? Yes, we can show that alpha. I'll write down the answer. I'll go for the next problem. The answer will be 3g by 8r. But I think it'll be taking that mg about this particular point, that then again the friction force will act, it will accelerate, solving that, because the center of mass of system is here. You have to jump to the center of mass system, not about point 2. I think we'll be taking very big risk if you want to try it. So what is the possibility of asking questions? I think maybe out of advanced paper, out of 18, maybe 1 or 2 of where you have to go for very hard thinking of this kind. 20% of paper will be where you have to put effort. The remaining 80% you can manage very comfortably. I'll go for the next one. First we'll see this. This will be